Hey friends, and welcome back to Science with Kenan. So far on this show, we've covered a lot of pretty big topics. From chemistry to psychology, rocketry to genetically modified organisms. So this week, I thought we'd take a tiny step backwards and ask a little simpler question. Something so fundamental and basic, I bet you even heard a kindergartner ask it before. You know, why is the sky blue? Ooh, pick me! I know. Alright, so the sky's blue because the Earth is made up mostly of oceans, which are blue. So, when the sun comes up, it just reflects off the oceans and shoots blue back up into the sky. Psh! Why is the sky blue? This guy. Not a bad guess, actually. I mean, the Earth's surface is covered mostly by water. But that can't be right, though, can it? I mean, if the sky were just a reflection off the ocean's surface, how do you account for the reds and yellows we see during sunrise and sunset? Oh yeah. Well, if that's not it, does anyone else have any ideas? How about you? Who, me? I don't know. I heard it was because there's a bunch of, water in the atmosphere, so that turns it blue. Like a big sky ocean or something. Ooh, a sky ocean. I like the sound of that. It's got a sort of majestic poetry to it, if you will. But no, that's not right either. I mean, first off, who keeps telling you guys that water's blue? The last time I checked, it seemed pretty clear to me. And secondly, that hypothesis still doesn't explain why we see the reds and yellows during sunrise and sunset. I bet you the answer is not even that hard. It's got to be something stupid and simple, like has to do with the color of space gases or something. Nope, no space gases. But I will say that the answer to why the sky's blue is actually even more complex than I'd even originally thought. So let's go check it out. Alright, so in order to understand why the sky is blue, we first have to grasp an understanding of how colors even work in the first place. How colors even work? What? Yeah, I bet you've never really even given a lot of thought into what color actually is. I mean, how do you make blue? Making blue? I guess I never really thought about it. See? So in order to understand how color works, we're going to have to jump into the world of physics. Physics. Yeah, physics. But don't worry, I'm here to break it down and make it as simple for you as I possibly can. So color comes from light, which is a form of energy. Now energy can come in many different forms, and often travels as either waves or particles. But for our purposes today, we're going to be talking about the energy that travels in waves, like the waves of the ocean. Some energy travels in long, slow waves, while others travel in short, choppy waves. The rate that each wavelength travels at is known as its frequency, and there's a whole spectrum of wavelengths that energy can be transmitted as. From really long, slow waves, like radio waves that we use for our cell phones, to short, choppy waves, like the UV radiation we talked about during our sunbathing episode. We can detect some wavelengths with our senses, such as sight or touch, while other wavelengths can pass right through us without us ever even knowing. For example, although we can't see infrared radiation, like some snakes and other animals, we can still sense it with our sense of touch through the form of heat. Hey bud, you could turn down the infrared radiation. It's getting a little hot for the suit, you know? Well, on the flip side, we're constantly surrounded by radio waves, from our TVs, cell phones, radios, Wi-Fi towers, yet we can't see them, taste them, or even they're there, but they're completely invisible to us. It turns out there's actually only a small sliver of wavelengths that we can actually see. These are between about 400 and 700 nanometers, and we call them visible light. Now, while some of this talk of wavelengths and energy may be a little to some of you, I'm sure we're all familiar with visible light, as we see it every day. Visible light is made up of red, orange, yellow, green, blue, and violet light, or more commonly known as the acronym, ROY-G-BIV. Now this may sound familiar to many of you as the colors of the rainbow, and you're right, it should. See, a rainbow is just created by the visible light from the sun being bounced around or refracted inside of raindrops and separated out into the wavelengths of each individual color. All you need is white light and a refractive surface to give you a rainbow. Red has the longest wavelength at around 700 nanometers, whereas violet or purple has the shortest at about 420 nanometers. The rest of the colors all fall in between. Now, when all of these colors are combined together, they give us what we see as white light. This is the kind of light that's sent to us by the sun. Now, this is the important part. So white light contains every single color of light, all mixed together. Now, when this light hits an object, some of the colors or wavelengths are absorbed, while others are bounced off and back out at us for our eyes to see. This is the whole basis of how we see everything in our world. It's crazy. Just think about it. This grass is only green because it's absorbing all of the other colors of light right now, except for green, which it's reflecting back out for our eyes to see. The same for this banana, except for with yellow. And these flowers, that house, my bow tie, they're all absorbing white light and reflecting out different wavelengths of color for our eyes to see. It's amazing. It's incredible. It's science. Whew. All right, I need a second. All right, now that we've nerded out together and we kind of have an understanding of how color works, let's see if we can use this explanation to explain why we see the sky as blue. So the sun is our planet's source of light, right? That big burning fiery orb of gas in the sky is constantly bombarding us with trillions of rays of blinding white light, from sun up to sundown. Now, if you remember, this white light is made up of every single color or wavelength of light, all combined together. That's red, orange, yellow, green, blue, violet, and every shade in between, all mashed up together to give us white light. Each of these colors travels at its own unique wavelength. Red light has the longest wave at about 700 nanometers and travels in long, slow waves. Whereas blue light has a higher frequency at about 475 nanometers and travels in short, choppy waves. This increase in frequency, or simply put, the fact that blue light travels more like this, makes it more likely to collide with the atoms and molecules in our atmosphere. When a wave of light hits a particle, it bounces off like a bumper car and is scattered in another direction. In science, the term for this is known as Rayleigh scattering, after John William Strutt, the third Baron Rayleigh, who discovered this back in 1904. Since blue light has a higher frequency than the other colors before it, it's the wavelength that's most often scattered throughout our atmosphere, saturating our skies in scattered blue light. Now, this doesn't mean that the other colors of light aren't scattered too. They're just scattered less frequently than blue light is, but we can still see their effect when we look up toward the sun. Oh, I can see other colors when I look up at the sun? Ah, I'm blind! Wait, no! I said toward the sun, not at the sun. Everybody knows you'll go blind if you stare at that thing. First, we have to throw on our stylish and protective eyewear of science, complete with lens shading and UV protection. Then, scan the sky, from away from the sun, toward it, and then back away again. You should notice that the sky is lighter around the sun, and then becomes a deeper shade of blue as you move away from it. This is because the closer you are to the sun, the source of our light, the more colors there are combined together, giving you a lighter, brighter white light sky. As you move away, less of the colors are being scattered around, leaving more blue to give you a more saturated blue-looking sky. Even though there's other colors being scattered throughout the sky, blue is still the most abundant and the most frequently scattered, giving our skies its classic blue look. Whoa, so the sky isn't actually blue then, it's clear? And the blue we see is just caused by blue light from the sun being scattered by gas and molecules in our atmosphere? Exactly! It's crazy, right? When you're looking up at the blue sky, you're really just looking at scattered energy. Billions and trillions and gazillions of wavelengths of light just scattered across the atmosphere, bouncing overhead of us. Whoa. That's heavy. No. It's light. Get it? It's light, cause it's light. If you're so smart, why doesn't your explanation explain why we still see reds and yellows during sunrise and sunset? Actually, it does. If you remember, we talked about the reason we see the sky as blue is because it has the shortest frequency, which allows the blue light to be scattered all across. But we also talked about red light having a long, slow wavelength, which allows it to penetrate through the atmosphere without being scattered as frequently. This means that when the sun is the furthest away from us, during sunrise or sunset on the horizon, light has to travel the furthest distance through the atmosphere in order to reach our eyes. This allows the more penetrating red, yellow, and orange wavelengths to reach our eyes, whereas the blues that get scattered go up and around us. These colors of wavelengths are separated by how often they're scattered, giving us these reds, yellows, and blues of the skies of the sunrise and sunset we're used to seeing. Okay, you did it. Mind blown. So color is just how we perceive different wavelengths of light. So the reason that we see the sky as blue is just because that wavelength is scattered more for us to see during the day, and then red reaches our eyes more as it penetrates during sunrise or sunset. That's right. All of this color and light that we see is just a result of our eyes' ability to detect different wavelengths of energy around us. The cooler your eyes are, the more types of energy you can detect. Like some snakes who can see in infrared, or insects or the mantis shrimp who can see in ultraviolet. Well, there you have it. The science behind why our sky is blue. I mean, there may be a few other things that go into it, such as how each of our eyes actually perceives light, and the actual spectrum of visible light emitted by the sun. But the basics all boil down to the Rayleigh scattering of blue light. Well, there you have it. Thanks for watching, and I hope you learned something. I know I did. Till next time, stay awesome, and keep curious, friends.